Okie dokie. Oh, hi. I'll mark you here eventually. We are having a mini lesson. It is just 2 class days. It is on scientific notation. It's just possible we as a math department have not taught you scientific notation well enough, so we want that. Plus, we want you to know how to use it on your calculator, so we're going to practice on the calculator you're going to use today. The lesson is today. There is no homework today. On April 20th and 21st, you'll do the homework on that time. So what scientific notation is, whether you know this or not, it is a way to express very large or very small numbers. That is what scientific notation does. You've probably done scientific notation in science class. Just curious, I'm going to do my lesson regardless. How many of you are very confident in scientific notation? How many of you are not? All right, so regardless of that, I'm still going to do that. All right, first of all, the very basics of scientific notation. I'm going to have this number here. Now, whether you think that's a large number or not, it's sort of a large number. Some calculators might not be able to deal with that. So the first thing I'm asking is we just write this in scientific notation. We just write it in scientific notation. And here's what we do. We always put a decimal, so it makes the number between 1 and 10. So what I'm going to do is put a decimal right here. When I put the decimal at 3.8, it has made this number between 1 and 10. So you write 3.8. Very often scientific notation is written times 10. And now, when it is a big number, we're going to have a positive exponent. Here's what you do. You go from this new decimal to where the real decimal is. There's really a decimal at the end of this number. And you count the spaces. You count the spaces. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is 10 to the 9th power. So this number here, which I've written all over, in scientific notation is 3.8 times 10 to the 9th power. Now on your calculator, it is hard to find scientific notation, especially if you have a TI calculator. It's not what you think. You cannot type 3.8 times 10 up arrow 9. It just doesn't seem to do it near as well as it should. It doesn't seem to do it near as well as it should. So, above your 7 key is a double E. Above your 7 key is a double E. And what we type to get this is we type 3.8. And you'll see the double E is the second key. You'll see the double E is the second key. So you go second, comma, which gives you a little E, and then you put a 9. And that turns out to be what the scientific notation is. It's weird to find. If you're on a different calculator, practice right now on the calculator you're on so you can find it. Practice. Calculator on so you can find it. All right, let's do another one. All right. That number, in fact, is an interesting number. It is the amount of raise I got this year. There's the raise I got this year. To make this into scientific notation, we put a decimal, make this number between 1 and 10. So we go here, and I put a decimal to make that 4.27. 4.27. So I write this as 4.27. When I'm writing it, it's times 10 to the. And now I count from the original decimal to the other. It doesn't matter which way you count. When it's a small number, it's a negative exponent. It's a small number, it's a negative exponent. So some teachers have you count one direction. It doesn't matter. Small numbers have negative exponents, so just count from one decimal to the other. Count the spaces. 1, 2, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And that number is 4.27 times 10 to the negative 15. Say, I'm getting it so far. Good. All right. Now, there's going to be some numbers, possibly at the end of an answer or something, that are going to be sort of scientific notation, but they're not. Might get some kind of answer of 328.47 times 10 to the 9th power. That will possibly be at the end of some kind of scientific notation problem. All right, well, that answer is not in scientific notation. So what we do, even though 328.47 is a small number, or you might think it's a big number, it depends. If it's how many dollars you got at your job yesterday, it's a big number. All right, here's what we do. We put the decimal to make the number between 1 and 10. We count 1, 2 times. 328 is in theory a big number. Anything over 1 is a big number. Anything a decimal number is a small number. So it's a big number. So this becomes 3.2847 times 10 to then we count 1, 2 times 10 to the 9th, which was already there. And then to get our number in scientific notation, we remember when we have common denominators, or common bases, we add the exponents. So that answer becomes 3.2847 times 10 to the 11th power. So how about now we have about 3 minutes of practice time. We have about 3 minutes of practice time. Would you please write these numbers in scientific notation? Couple of minutes of practice. It's hard to count on your desk when you can't count them, but I think I counted right. Maybe you did too. 4.86 times 10 to the 14th. Go woohoo. 7.3 times 10 to the negative 6. And 8.49 times 10 to the 19th. Woohoo, woohoo, woohoo. All right. Awesome. All right. It is hard to count zeros when you don't have them to count. All right. Psi naught, scientific notation. Our next little objective is this: to express in scientific notation, then to multiply with no calculator. All right. Would be confusing to do on paper with no calculator, would be difficult. One, two, three, four, five, six. 9. And now, it's just regular 8 times regular 2, just like regular, 16 times. When you're multiplying the common base, you end up adding the exponents. Why is that again? Because 10 to the 6th is 10, 10, 10, 10, 10, 10. 10 to the 9th is 10, 10, 10, 10, 10, 10, 10, 10, 10. You can check on the video if I counted right. And there should be 15 if I did that right. Do you walk away happily with the answer 16 times 10 to the 15th? You do not, because you need to put the decimal here, move it once. It is 1.6 times 10 to the 1st times 10 to the 15th. This answer is 1.6 times 10 to the 16th. Would you now on your calculator please try 8 times 10 to the 6th times 2 times 10 to the 9th, so you can do it right on your calculator. Another objective is that we can do it right on our calculator. If you can, say, I can.
I can.
Good, one of you can. 2 of you can.
I can.
3 of you can. 4 of you can. Now we're getting somewhere. All right. There will be question time after this. There will be question time after this. All right. We're going to do one more. First on paper, then on calculator. First of all, with no calculator, express in scientific notation. And then with no calculator, multiply and express with scientific notation. Do I need to stop the video? Soon.